Humans have 5 senses: the eyes to see, tongue to taste, nose to smell, the ears to hear, and the skin to touch. By far, the most important organs of sense are our eyes. More than 80% of our brain's activity has to do with vision. We perceive light with our eyes. The light rays come to a focus on the retina. The stimuli get transmitted via the optic nerve to the brain, and this is where vision happens. So the ability of our eyes to focus light, the ability of the brain to interpret the stimuli received, is what creates vision. Now let's take a look at the way we see. Looking at this image, you see light reflected off the soccer ball coming to the eye through the cornea pupil lens, coming to a focus on the retina, being transmitted via optic nerve to the brain, and this is what we call perfect vision. We measure vision with the Snellen chart. This is a chart that was invented by Professor Herman Snellen. He was a Dutch eye doctor born in 1834, invented this chart, and so we have had this for quite some time. We are looking at the 20/20 line. This is defined as what a person with normal vision can see from 20 feet away. If this happens, we say that this person has 20/20 vision or perfect vision. Now, a person that can see 20/40 has, of course, decreased vision, because this is what a person with normal vision could see from 40 feet away. So to put this in perspective, in order to pass your driver's license test, you need to have a minimum of 20/40 vision, and that is true for all 50 states. So what really needs to happen in order to create this ideal stage where we have this normal 20/20 vision? So again, here you see light reflected off an object and comes first to the cornea. For the ideal state to happen, this cornea needs to be cylindrical, shaped like a basketball. It needs to have the same refractive power in all meridians. The light then continues through the cornea, through the crystalline lens, a nice clear lens, and comes to a focus on the retina. To make this happen, the eye needs to have about 62 diopters of focal power. 2/3 of that power happens on the cornea, about 43 diopters, and 1/3, about 19 diopters, in our lens. When this all comes together in this ideal state, we call this emmetropia. Emmetropia means there is no refractive error in this eye. It's just perfect the way it is. Now, of course, there are refractive errors because the ideal state is not always achieved. Those refractive errors are called emmetropias. It just means that there is something not quite right, something is off, the vision is blurry. The most common refractive error is myopia. In myopia, parallel incoming light comes to a focus before it reaches the retina. That, of course, causes blurry vision. We go ahead, we add a concave lens, a minus lens to this system. The minus lens diverges light to then come to a focus on the retina, again restoring the clear, perfect vision. Myopia most of the time happens because the eye has a structural deformation. It is too long and has too much plus power. The opposite, of course, is hyperopia. In hyperopia, parallel incoming light comes to a focus behind the retina. So we go ahead, help the whole visual system out. We put a convex, a plus lens in front of the eye, which then converges light so that it comes to a focus on the retina. This condition of hyperopia happens because, in most cases, because the eye is too short and has not enough plus power. Little bit different in astigmatism. In both of these other conditions, we were looking at a basketball-shaped cornea which has the same refractive power in all meridians. So a dot is going to remain a dot. So what is a dot is going to be a dot focused on the retina. When we have astigmatism, the cornea is shaped more like a football. The cornea has different powers in the two premium meridians. So what happens to our dot? Our dot gets elongated to a line. So what we need to do in order to correct this, we have to have a lens that also has two powers to correct. So we take a cylinder lens and add it to this visual system. And once again, we bring everything to a focus on the retina to restore clear vision. Presbyopia. Now, presbyopia is a result of the loss in elasticity of our crystalline lens, and it causes a weakening in accommodation. Accommodation is needed for the eye to focus on intermediate and close-up objects. Typically, in a younger person, this happens thousands and thousands of times during the day. We have little ciliary muscles that support the lens in changing its shape so that it bulges out a little bit more to create more plus power to focus on intermediate and close-up objects. This around age 40, and it's a little different for each person, but right around that age, those muscles in the lens kind of like are tired. They are just simply, they don't want to do it as often and as much any longer. The result is that close-up objects do not come into focus clearly. What we most of the time notice first that, people hold their reading material out further, and then it comes to a point where then they cannot read the small print any longer, and then something needs to be done. So once again, we just go out and support the eye by adding a convex lens to the system and restoring clear vision by bringing focus on the retina. Vision is a most remarkable sense. It is a gift, and it is the gift that we can give to so many of our patients.